All right, today we're going to do section 2 of chapter 3, which deals with quadratic equations, quadratic functions, and the zeros of quadratic equations, quadratic functions. The process we're going to take to find the zeros is I'm going to show you, actually, I'm going to first show you how to factor. Then we'll go to a method called complete the square, and then we'll finish up using the quadratic formula. And then we'll talk about what's called a discriminant. It's part of the quadratic formula. And to do all this solving the zeros, we're going to have to talk about these two principles, the principles of zero product and the principles of radicals. So that is our agenda for today. As we talked about last time, there are two forms in which quadratic equations can be given to us. The standard form, and the other method is called the vertex form. The standard form is f of x equals ax squared plus bx plus c. And the vertex form is equal to a times x minus h squared plus k. And these two forms have their own pros and cons. Very important. A, B, and C are numbers. They're not x. A is the coefficient of x squared. B is the coefficient of x, and C is the constant. Because you can't, when I ask you to label A, B, and C, you can't tell me they're x, like 5x or 1x. They're just numbers. All right, and the reason this one's called vertex is because as the equation for the circle, we had x minus h, y minus k. That's what these are for. The h and k define where the vertex is. That's why it's called the vertex form. And I'm going to show you how you could just look at these two types of forms of equations and tell me a lot about the graph before we do any graphing whatsoever. So let's talk about solving quadratic equations. You're going to hear quadratic equations, quadratic functions a lot. Let me show you the difference. The quadratic equation is the quadratic equation set equal to 0. Because remember, equations you solve. The quadratic function is simply the way you write it. So those are the differences. Yeah. Thank you.
Thank you.
You're more than welcome. So whenever you hear quadratic equation, you know, equation, everything on one side set equals 0. A quadratic function is simply the function notation equals the equation part. All right, so when we say solving, let me first say that this word has two other ways, not three other ways you can say it. When we say solve, what we're looking for are the x-intercepts They're also called the zeros. And we'll also get later on called factors or roots. So, but for these words are interchangeable. If I say solve, or find me the x-intercepts, or find me the zeros, they all mean the same thing. There are three ways we can do this. There are three ways we can solve a quadratic equation. Three methods. The first method is by factoring. Factoring is when you take a bigger equation down and break it down to its smaller pieces. And this only works if the equation is factorable. As we'll see, not all equations are factorable. The second method is called complete the square. This method always works, but can be confusing when you're dealing with fractions. And the last method is called the quadratic formula. And this one always works. It gives you the least of all troubles. You may ask, then why don't we just learn how to use the quadratic formula? But sometimes you could look at some of these equations and factoring would be much faster. Or when you're looking for a vertex or one in another form, the complete the square may be easier because it'll put it in a whole different formula. All right. So the first thing we're going to talk about are factoring. Breaking large equations into smaller equations. What our goal will be take this trinomial quadratic equation break it down to two binomial linear equations. That's our goal. Actually, that's going to be our goal for the rest of the semester. We're going to take larger equations and break them down into smaller binomials. Why are these called binomials? Because they have two terms. This one has three terms, so it's a trinomial. Right, so let's look at how to factor. First, we're going to start off with the solution and work our way backwards. So I'm going to give you 4 binomial pairs. They're going to be the same number and same letters. The only thing different will be the signs between them. And this will help us see things to make things a lot faster for us. So go ahead and multiply these out together. And there's always a checks and balance going on here. Finish by this. So again, it's the checks and balance. You guys probably learned this as FOIL technique in high school. But FOIL technique only works when you have binomial times binomial. If you have anything else, you can't use the FOIL technique. So it's just easier to memorize. It's distributivity. Everything in the first parenthesis multiplies everything in the second. We have 2 terms here, and we have 2 terms here. When we multiply them together, our first step, we should have 4 answers, 4 terms. Let's see. X times x is x squared. Positive times positive. X times 3 is 3x. So that finishes this one. Positive times positive is positive. 2 times x. Positive, positive is positive. And 2 times 3 is 6. There are our 4 terms. If you don't have 4 terms, you did something wrong. Whenever you get rid of parentheses, the first thing you always have to do is combine like terms. So positive 3, positive 2, they're both positive. And we get that. Repeat the process. X times x is x squared. Positive times negative is negative. X times 3 is 3x. Positive times negative is positive. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Combine like terms. Negative 3, positive 2. 3 is bigger, so the answer is negative. 3 minus 2 is 1x minus 6. X times x is x squared. Positive times positive is positive. X times 3 is 3x. Negative times positive is negative. 2 times x is 2x. Negative times positive is negative. 2 times 3 is 6. Combine like terms. Positive 3, negative 2. 3 is bigger, so it's positive. 3 minus 2 is 1. X. And the last one. X times X is X squared. Positive times negative is negative. X times 3 is 3X. Negative times positive is negative. 2 times X is 2X. Negative times negative is positive. 2 times 3 is 6. Combine the like terms. They're both negative. Add the numbers. That's called distributivity. When you go this way, it's called distributivity. Factoring goes the other direction. When you factor, you're going from higher exponents to lower exponents. So here are the steps. Remember, our equations are standard form. These are all in standard form. What we're going to look at first is if A, our leading coefficient, is 1. The rules change a little bit when your leading coefficient is different. First step, set the equation equal to 0. So we have x squared plus 5x plus 6 equals 0. We're doing the first one. If A is not 1, then divide each term by A. Now we start factoring. So what we want is we want to put that into our 2 parentheses. First step. Look at the first term. What 2 numbers or letters multiply to equal that term? So what makes up x squared? Yeah, they go in the first spaces, x times x. They go into the first spaces. All right, second step. Look at the second sign. This is the second sign. If it's positive, then both signs are the same. And they are the first sign. If the second sign's a positive, then that means the signs are the same. They're whatever the first sign is. So that means they're both positive in this case. If it's negative, then both signs are different. You're going to have one plus and one minus inside the parentheses. Okay, since the second sign is plus, it's going to be both pluses. Third step. Find what two numbers multiply to equal the third term. So we're doing what times what is equal to that last term, the C number. That when you add or subtract, depending on the second sign, when you add or subtract those numbers, they equal the middle number. So what two numbers multiply to give you 6? When you add them, you get 5. 2 and 3. That's what this last one says. Find two numbers and multiply equal to the last term, that when you add or subtract them, depending on what the second sign is, then you get the middle term, the middle coefficient. Set both equal to 0 and solve for x. So I set both of these equal to 0. And I solve. So these are my solutions or my x-intercepts. That's where the graph is going to cross the x-axis at those 2 points. Why do we set them both equal to 0? It's called the zero product principle. Or you could say it's the product of the principle of zero products. What this thing means is this. If I have two numbers and I multiply them and they equal 0, what has to be true? If two numbers multiplied equal 0, what has to be true? Either A equals 0, because 0 times anything is 0. B equals 0, anything times 0 is 0. Or A and B are equal 0. Since we don't know which ones, we set them both equal 0. Since we don't know which one, we set them both equal to 0, and that's our answer. Make sense? Let's look at the next one. Example 2. We have x squared minus x plus 6, minus 6 equals 0. A is 1. So we just go ahead and make the parentheses. First step is look at the first term. What times what equals x squared? X times x. Then look at the second sign. It's a minus. That tells us what? That the signs are opposite. One's going to be a positive, one's going to be a negative. Ooh, I forgot to also tell you this. If the second sign is negative, there's one's positive, one's negative. The bigger answer gets the first sign. That's what that scribble is there. If sorry, if the second sign's a minus, that means the bigger number when we find the answers, the bigger number gets that sign. Because when you put them together, they have to equal negative. So that's what that says. If both signs are the same, if the negative second sign is negative, but they're both different, and the bigger answer gets the first sign. So now we look at the last number. What times what equals 6? When we subtract them, we get 1. What two numbers equal 6 when you multiply them? 3 and 2. And when you subtract them, you get 1. You get 1. So that means the 3 goes here and the 2 goes there. What if I gave you this? X squared minus 2x equals 15. Solve that one. What's my first step? Right, because it's an equation, it has to be set equal 0. So we have to add 15 or subtract 15 to both sides. Now we can try to factor it. So the first step is what makes up x squared? X and x. The second sign's a minus. What does that tell us? Opposite signs. Very good. And the bigger number will be negative. So what two numbers multiply together to equal 15? When I subtract them, I get 2. 3 and 5. So 5 times 3, 5 minus 3. So those are my two numbers. Since the first sign is negative, the 5 goes with the negative. 3. Set them both equal to 0. And solve. And as I said many times before, if it happens inside a parenthesis, it's always the opposite. If I have x plus 3, the answer is negative 3. X minus 5, the answer is positive 5. What do these represent? Those are my zeros. Those are, if I plug these back in the original equation, it'll equal 0. So what are my x-intercepts then? If these are my zeros, what are my x-intercepts? Excellent. It's a point. It's a location. Depending on what the question is asking. If it's asking for zeros, just tell me this. If it's asking for x-intercept, it's a location. Give me those. Now things change. Now we're going to look at equations where a does not equal 1. I know I said last time, the first step should be divide everything by a if you have a non-1 coefficient. But if we do that, then we'll have a fraction here. Let's not do that. Here are these steps. Steps when a does not equal 1. Remember, we were trying to factor this. Put ax in the first part of both parentheses. So whatever this number is, put it in the first parenthesis. So 6x times 6x. We'll fix it at the end. So whatever this number is, it goes into both of them with the x's. Look at the second sign. It's a minus, so that tells us the signs are different. Here's where it gets different. Multiply a times c. So in this case, remember we have ax squared plus bx plus c. And don't worry about the signs. A is 6. B or C is 12. Multiply those two together, I get 72. Then find out what two of those numbers added or subtracted give you B. In this case, 1. So here's where it gets complicated. So now we figure out what equals 72. So we have 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9, and that's it. Because then we start repeating themselves the other way. So now we look at these numbers here. Since it's a minus, when you subtract these, which one of these equals 1 when you subtract them? 8 and 9. So our numbers we know are 8 and 9. The first sign is a negative, so 9 goes there, 8 goes there. The larger number gets the first sign. Step 6. Factor out a common factor from each parenthesis if possible. What do 6 and 8 have in common? Yes, they both have a 2 in common, so I take out a 2. To tell you what goes inside there, since I factored out the 2, I divide each of these by 2. 6 divided by 2 is 3x. 8 divided by 2 is 4. Since I took out the 2, I divide them. 6 and 9. They both have a 3 in common. So I divide those. 6 divided by 3 is 2x. Minus 9 divided by 3 is 3. Erase what you factored out. So erase the 2 and erase the 3. Those are your factors. Then solve. 3x plus 4 equals 0. 2x minus 3 equals 0. Solve for x. Be negative 4 divided by 3. The 3 goes over, so it's positive 3 divided by 2. And these are your x-intercepts, your solutions. Let's do another example. 12x squared plus 13x plus 3 equals 0. What goes in the first spaces? 12x and 12x, whatever this first number is, and the x's. How about the signs? Yeah, they'll both be the same. They're both going to be positive. Then we do what? Multiply the first and the last numbers. Equals 36. Here, we got to figure out what two numbers multiplied equal 36. That when we add them equals 13. So let's see. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. That's it. So now, which two of those, when you add them, equal 13? 4 and 9. That was the hardest part, is finding out all the multiples. Now, in each of these terms, factor out what they have in common. What do 12 and 4 have in common? 12 is made up of 3 times 4. So I can factor out a 4. And to see what goes inside there, I divide both of those by 4. 12 divided by 4 is 3x. 4 divided by 4 is 1. What do 12 and 9 have in common? They both have a 3. So I divide both of these by 3. 12 divided by 3 is 4x. Plus 9 divided by 3 is 3. Erase what we just factored out. Now solve them. So this will be opposite signs, so it'll be -1 divided by 3. -3 divided by 4. Those are your solutions. Yes.
So when we got to the 4 times 9 part,
Yes.
to figure out if it's added to equal 13.
Mhm.
But on the previous equation, we subtracted it. So what sign does that depend on?
Okay. On this one, this last example. Oh no, on the other side. On this last example, since the second sign was a minus, we know the bigger number gets a negative. So the bigger number, once we figure out what two numbers we have, 8 and 9, since the first sign is a minus, this one gets a negative. And that's what we did there. 9 gets a negative. Since they're both the same here, it doesn't matter where I put them. Yeah, so it's the bigger out of these two numbers gets that first sign. Actually, it even works right here. Even if they're both the same, we know 9 has to be positive and 4 goes in the other one, which is also positive. To graph a quadratic equation, you need the following. The x-intercepts, which we just figured out how to get. And you need what's called the vertex. The vertex is the highest or lowest point on the graph. That's called the vertex. And you can tell me whether you have the highest or lowest. It's the highest if the graph looks like this, it's the maximum. It's the lowest if the graph looks like that. It's the minimum. We can tell how the graph is going to look just by looking at the equation. So here's our quadratic function. Since the largest exponent is a square, we know that it's a quadratic equation. Because it's a 2, we know the graph looks like this or like this. Library of functions tells you that. We know the y-intercept. Now, what differentiates whether it points down or points up is this term here, is the a term, the number in front of x squared. If a is negative, it points down. If a is positive, it points up. And again, if it points down, then we have a maximum. If it points up, we have a minimum. So here, we know, okay, now we know the y-intercept, or x-intercepts here. By looking at the equation, what else can you tell me about the graph? What direction is it opening? Do we have a maximum or minimum? It's a is positive, so it looks like this. So we have a minimum. And the y-intercept is 3. So we at least know that the y-intercept, one of them, will be on 3. So what we need to know is where the vertex is, because if the y-intercept is 3, the graph can look like this, or the graph can look like this. We don't know which one until we know the vertex. If the vertex is here, then we know it looks like this. So how do we find a vertex? There are 2 ways. The first is algebraically. Negative b over 2a remember, an equation is ax squared plus bx plus c. So you're using the coefficients of the x squared and the x. Once you get those, you put those back in the, once you get that number, you put it back in the equation, and that gives you the y value of the vertex. That's one way of doing it. The other way is put your equation into the vertex form. And the vertex here would simply be hk. Again, it's the opposite sign of what's inside the parentheses, and outside it is what it is. Let me see some examples here. Yeah, let's make one up. Ooh, also, I forgot to tell you. Once you find the vertex, It's a point. Let's say it's the original function, x squared. What is A, what is B, and what is C in this equation? A is 1. Yep, that's the coefficient of x squared. Do we have a B? No. Do we have a C? Nope. So those are both zeros. Let's look at the formula we just had. Negative B over 2A and inside the function. So when we solve negative B over 2A, we got negative 0 over 2 times 1. 0 over 2 is 0. That's how you find the x value. Once you find the x value, plug it back into this equation you started off with. So y equals x squared. X is 0. 0 squared is 0. So it's 0, 0. That's the vertex. Yep. That's exactly what we say it is. And we know it's going to be a minimum because A is positive. A is greater than 0. So we have a minimum. So let's look at a bigger equation now. Oh, you notice we talked about in chapter 2 symmetry. Quadratic equations are symmetric. This side of the graph looks like this side of the graph. So if I gave you a point here at 2, 4, if I just had that point, I would know that there has to be one on the other side at negative 2, which also equals 4. That's symmetry. In other words, it's symmetric about this line here. That's called the axis of symmetry. And it has a formula. The axis of symmetry is simply the x value of the vertex, in this case, 0. The x value of the vertex is the axis of symmetry. Once you find it, just draw a vertical line, and whatever you have on this side, it mirrors the other side. Which one am I going to use? Graph this. Okay, first off, we know we can't factor this one. How do we know we can't factor this one? Give me two numbers that multiplied equal 23 that when we add them, you get 10. 23 is a prime number. So we can't factor that. So instead of wasting all your time with that, I'll show you another method in a second. So first, find me the vertex. And then the x-intercepts. So to find the vertex, label A, B, and C. What is A? 1. What is B? 10. And C is 23. So the x value of the axis of symmetry, or the vertex, is the axis of symmetry, and it's negative b over 2a. So it's negative 10 over 2 times a. A is 1. Negative 10 divided by 2 is negative 5. So the axis of symmetry is at x equals negative 5. But to find the vertex, we have to take this number and put it back into our equation to find the y value. The y value is that function at your x-intercept, or x value. So we have x squared plus 10x plus 23, negative 5 squared, 10 times negative 5 plus 23. Negative 5 squared is a positive 25. Positive times negative is a negative. 5 times 10 is 50. Plus 23. 25 plus 23 is 48. Minus 50. 50 is bigger, so it's negative. 50 minus 48 is 2. So that's my y value. So my vertex is at negative 5, negative 2. So I know then my graph, I know I have a y-intercept at 23, and my vertex, 1, 2, 3, 4, 5, is down here. So I know my graph will look something like this. But we're not finished. We can't finish graphing it. Well, we can find one other point. What other point can we find? We know this point is at 0, 23. And it's, remember, the axis of symmetry is right there. So this point is 2 spaces to the right of the line, which means I could go this way, 1, 2. It's going to be at negative 4, 23. There's another point because of symmetry. The axis of symmetry is negative 2, so 2 spaces to the right, up 23. 2 spaces to the left, up 23. You see how that works? If I had a point here at negative 115, my axis of symmetry is negative 2. So it's 1 space to the left and up 15 points. There has to be a mirror 1 this way and up 15. It is. Oops. I misread it.
Oh,
Yes. Yeah, I'm sorry. Yes. Forget everything I just told you there. Our axis of symmetry is at -5, -5, -2. It's over here. And it crosses at 23. I'm sorry. Yes, I had it backwards. So if I go 5 spaces this way from this point, from this line here, if I go 5 spaces this way and up 23, I can go 5 spaces this way and up 23, and I have the other half of my graph. Graph. So that's how we find the point. We know where the vertex is, we know where the y-intercept is, so we can find its mirror image. Now, how do we find the x-intercepts? Well, we know we can't factor it. So let's use our first method to complete the square. And I'm just gonna give you a heads up here that to complete the square method works best is if you have an even integer in the middle. After you get your leading coefficient to be 1. Here are the steps. Set equal to 0. A has to be equal to 1. You have to have a 1 in front of the x squared. If not, then divide each term by A. No, when your leading coefficient is 1, if you have an even integer in the middle, then it's much easier. Because if you don't, then you'll have fractions and it'll make it much more painful at the end. So, but it'll work both ways. It's just that it'll save you some time if it's an even integer. Step 3. So I set it equal to 0. I move the constant term to the other side. So I have x squared plus 10x equals 23, or -23, I'm sorry, because I moved it over. I subtracted 23 from both sides. Step 4, add b over 2 squared to both sides. Remember, whatever you do to one side, you have to do to the other side. And don't worry about if b is negative, don't worry about it, because when you square it, it becomes positive. So just put the number in there. So what is b? In our example, what is b? B is the coefficient of x. So we add 10 divided by 2 squared to both sides. On the left side, only do inside the parentheses. Don't square it. Ten divided by 2 is 5. So leave it squared. The right side work it out. So we have negative 23 plus 5 squared, negative 23 plus 25 equals 2. Ten divided by 2 is 5. 5 squared is 25. 25 minus 23. Now here's where we actually complete the square. On the left side, this is the only side you're going to do. Inside a parenthesis, put what is under the squares. Put the first term here. That should be squared. So whatever's under the square, whatever's under the square, and the first sign. So the first term, first sign, and then the last term. So whatever's under the square goes inside here and here. Whatever the first sign is goes in the middle. You complete the square there. Now, if you want to know the vertex, if you want to know what the vertex was, if you're looking for the vertex, just set it equal to 0. In other words, if you set this thing equal to 0, you have x plus 5 squared minus 2 equals 0. So the vertex would be what? Opposite of this one, which is negative 5 and negative 2. Remember, anytime you have anything inside of parentheses, it's always the opposite. So it's x plus 5, it becomes negative 5. And then negative 2. That's the vertex. That's just a side note. Now, solve for x. From this point on, solve for x. Here's a very important note. If I have anything squared equals a number, for example, 2 squared equals 4, negative 2 squared also equals 4, right? So if I have x squared equals 4, and I square root both sides, this answer can be positive or negative 2, because both of these gave me the same answer. That's called the principle of radicals. Whenever you square root something that's squared, you put a plus or minus in front of the answer. So here, when I square root both sides to get rid of this square, I got to put a plus or minus in front of the other side. I'm taking the square root of both sides, but on this side, I have to put the plus or minus. On the left side, the square and the square root cancel, so we have x plus 5 is equal to plus or minus radical 2. Get rid of the 5, so subtract 5 from both sides. So x equals negative 5 plus or minus radical 2. And these are your two solutions. You have one of them at negative 5 plus radical 2, and you have one of the intercepts at negative 5 minus radical 2. These are your two different solutions. That's why we couldn't factor them. Okay, so we know this is our answer here. These are our x-intercepts. We found the vertex. We know what A is. A is positive, so it opens up. We know we have a minimum at the vertex, and we know where it opens. We have the x-intercepts now. Now we just connect the dots and go. We're done. Let's look at the last method. Typically in this class, what I do, I start off from a standard form equation. I do the complete the square, and I get us to the quadratic formula, which is our last method. To find the x-intercepts. The quadratic formula works best if you're in standard form. Now, the reason I say that, because if I gave you an equation in vertex form, if I give you an equation in vertex form, just solve for x the way we just did. Move the 4 over. Divide by 2 both sides. Square root both sides. So we have x minus 5 equals plus or minus square root of 2. And then move the 5 over. So if you're in vertex form, just complete the square. Just move it over in square root. Now, if you're in quadratic form, first step, label A, B, and C. These are important. If there's a negative in front of the B and C or A, those have to be negative inside here. You have to keep the sign with the number here. Just plug it into this formula. And it'll do the work for you. So we'll use the same example we had last time. It's x squared plus 10x plus 23. So first step, let's label A, B, and C. A is positive 1, B is positive 10, and C is positive 23. Negative B plus or minus B squared minus 4AC over 2A. I always start off writing the formula down and just plug and play. So we have negative B is 10. B is 10 squared. A is 1. C is 23. And A is 1. If these numbers are negative, before you put them in there, put them in parentheses. So it'd be like if B was a negative 10, you have a negative of a negative 10. And negative 10 in parentheses squared. Let's work these out. 10 squared is 100. Negative times positive is negative. 4 times 1 is 4. 4 times 23 is 92. And 2 times 1 is 2. We have negative 10 plus or minus 100 minus 92 is 8. Let's fix the square root of 8. 8 is made up of 2 times 4. It's made up of 2 times 2 times 2, right? Since it's a square root, if you have 2 of a kind, they can come out. So it's 2 square root of 2. Negative 10, 2 square root of 2. So that becomes that, and that becomes that. On the top, 10 and 2 both have a 2 in common, so I can factor it out. And the 2's cancel. So our answer is like we thought. The quadratic formula always works. So I'm not going to be one of these instructors, okay, you have to use this method to solve it, because all I'm looking for is the answer. Whatever method you want to know, but you have to know how to use all 3 of them. Because we're going to be using all 3 of them in the next few chapters. Okay, here's the last question. I'm going to set up for you because it's almost time to go. If I gave you this, and I asked you to find the solutions, x-intercepts, how would you do it? Rewrite the equation. Remember, has to be equal to 0. And everything has to be to one side right now. Remember what I said in the second week of school, that whenever you have fractions and an equal sign, always get rid of the fractions. What's the LCD in this example? 2. It's the only denominator. So multiply each term by 2. So 0, the 2's cancel. So it's x squared minus 8x plus 16. And from there, we could solve it. Can we factor it? What times what is 16? When you add them, you get 8. So they're both the same signs. They're both minus. 4 times 4 is 16. And so our only answer we have here is this. What does that tell us? If both of these answers are the same, what does that tell us? X is 4. So we know we have that means that's our lowest point. That's our vertex. We know our y-intercept is 8. 1, 2, 3, 5, 6, 7, 8. So I got a point there. So that means 1, 2, 3, 4. If I go 4 to the right, I go up 8. I got another point. If you only have one solution, that means your graph only touches the x-axis at one place. That's the vertex. That's also the axis of symmetry. And that's it for today. Yeah, that's it for today. Actually, that's it for the week.